Welcome, and today we are going to introduce our lab final. So you have made it to the end of Chem 1, and hopefully on the front of this, please put your name, my name, the block, and then your return date, folks. You don't need to fill that in yet. And so this lab final was actually originally created by two teachers that I taught with at Millard South High School, and so their names are listed on the bottom, and we have given them credit for letting us use this lab. And so what we're going to be doing is you're going to be getting one unknown at the end of class today. You'll have a total of 3 of these to do between now and the end of class next Thursday for us. So you basically get, today included, a total of 5 days on your lab final. So each one of these requires you to do some different tests and identify this unknown. So this is basically an ionic compound. So we have a cation and an anion that are represented in here. So to see what your possible options are, let's take and kind of browse through this for just a second of our packet. So on page 2, notice it's got some general instructions that you can read and we'll look at here in a little bit. We also have some rules of lab conduct. So that will be something we look at on page 3. Then notice on the top of page 4, we have positive ions and negative ions. So this is a list of all possible cations that we could have. You have to have one cation and one anion. Okay? There could be any combination of these. And so you are running tests to figure out what ionic compound do you have. You'll have one cation and one anion. Down below here, it gives a list of reagents. And so what reagents are, is those are aqueous solutions that we have prepared ahead of time for you. And so right over here in the trays that we're used to using for lab, you have a prepared group of reagents for you that we'll be using. And so along with that, there are 4 microspatulas, and then you will have access to a flame test wire that we will see also here in a little bit. What we're going to do today here in a minute, after we look at some beginning things, is we're going to actually go through preliminary tests, and we're going to do this unknown together. Okay? So what I want you to do right now is go back on this at this moment to page 2 and page 3, and I'm going to give you a couple of minutes to go ahead and scan through page 2 and page 3. Just leave that on. No, leave it on. Yeah. Okay, I'm going to highlight a couple of these things for you. First of all, if we are adding water, we want to always be using deionized water or distilled, and so that is in bottles for you. Notice you're adding 5 to 6 drops of water. If you're using a different type of reagent, something like silver nitrate, you're only going to use 1 to 2 drops. You're also going to be using this spatula, and it's a micro spatula because we're using very small amounts of our unknown for our test today. Then, if we're highlighting some of the safety items, one is you have to have your goggles on. And so if you need a break at some point during lab, you may come back over to the seating area, take your goggles off. You can look up things on your Chromebook. You can look up things in other packets. If you need a drink of water, it will all say over here. And so all of our normal lab rules will apply. Anytime you're in lab, there will be your goggles are on, no food or drink, and you cannot have any electronic devices over in the lab area. Okay, but you're willing to you can access those at any time over here in the classroom area. A couple of other things that I want to keep in mind is if we are smelling something, make sure you're wafting. Okay, don't smell it directly. Also, as we are dealing with waste, there will be some different instructions throughout your packet that will tell you certain things need to be disposed of. So if it is a precipitate waste that needs to go in the precipitate waste container, please access that in the fume hood. Okay, if you have questions about disposal, that is definitely a question that you can ask me. All right, so at this point, let's go ahead and go on and let's look at page 5, which is the preliminary test, and we're actually going to run through some of those for our unknown. We are also going to be filling out our sample sheet, which is found at the very back. So notice the sheet right here that says results for unknown. Okay, we're going to be flipping back and forth here, and we're going to be filling this out so you have an example to follow as you're doing this throughout next week. So the first thing we're going to do is an inspection test. So you're going to look at your unknown. You can open this up. You can waft a little bit. Don't pour it out into a weigh boat because you'll be wasting some of the material. And so as we look at the inspection for this, we are going to write down some information for that. And so at this point, turn in your packet to the page that has sample on it. I'm going to bring up one that is up here for me. I'm going to scroll up just a little bit. So you should have a sample sheet in your packet that looks just like this. And the first thing I have for my inspection test, that it is moist and pale violet. This sample sheet of this will be able to be found on Google Classroom later today, and it'll also be posted throughout the room in case you're having a hard time keeping up with some of that. So at this point, I'm looking for anything that would be a possible ion. Well, as I look through my information, so if I go to the cation section and I look at my ions, I'm looking to see, mine kind of has a pale violet, so I'm looking for anything that says it could potentially be a colored compound. And as I look at this, I notice that iron can be colored, I look at copper could be colored, and I also notice that nickel could be colored. And so I'm going to write over here, my possible ions could be copper, could be nickel, and it could possibly be iron. The reasoning it could be any of those three compounds is because they are colored. All right, so then we're going to move on to our second test, which is going to be water solubility and litmus test. You will add water to a small sample of the unknown, about a fourth of spatula, and pay special attention to the amount of water needed, the color of the solution, and the acid-base properties of the solution. And so then it's going to give us some additional things that we're going to want to do with that. So at this point, I'm going to use some test tubes, and so each person will need 4 clean, dry test tubes. So this first one is you're going to add a small amount of your sample, about a fourth of a spatula, to that. So I'm going to take my spatula, I'm going to take a clean, dry test tube, and I'm going to grab about a fourth of a spatula full of this. The most important thing is that you're keeping a consistent amount that you're putting in so that you have the same concentration each time. So at this point, my unknown is on the bottom, and now it says that we're going to add a drop of water, 1 drop at a time. We're going to add a total of 5 to 7 drops, but I want to see basically how quickly that this dissolves. So 1, 2, 3, and I can see really after about 3 drops that has dissolved, so 4, 5. And so at this point I'm going to remain consistent here, and I've got 5 drops for my water solubility test. And so now at this point I'm going to set this aside for a second and come back to this up here, and for my solubility test I'm going to write that it dissolves quickly. Okay, and at this point, folks, I don't really know, and and I don't really have anything I'm going to get information for on that component at the moment. So I'm going to leave that blank and probably come back to that after I have a little bit more information. Okay, the next thing I'm going to be doing is a pH test, and there are a couple of different ways you can do this. You can go ahead and use this and basically try with pH paper, which we've used, red and blue litmus paper, or probably the thing that we have used most common is universal indicator. And so I'm going to go ahead and put a drop or two of universal indicator in there. Sometimes this can be tricky if you have a colored compound. Other times it's easy to tell, so you just have to decide which one you need to do. So I have now added a drop of universal indicator, and it is red, so we know that it is what?
Acidic.
Acidic. Very good. So pH test observations, it is acidic. Okay, I also do not have any specific things for that right now. I do know acidic, I'm going to look for my pH chart. And if I'm looking at my pH chart, I know that it's very acidic. And so we probably have something around a pH 1 or 2. Okay. Possible ions, I still don't really know anything about that at the moment, so we're going to leave that blank at the moment. The next thing I'm going to have to do is a flame test. And so in order to do my flame test, I'm going to use a flame test loop. I can also use a wood splint, which I've used a couple of different times. If you're doing a flame test loop, you have to potentially clean this first, and there are instructions for that over on the middle island. I've already cleaned this flame test loop, and so at this point I'm going to just show you how to use it, and I'm going to tell you what the flame color is. We have done flame tests before. Hopefully you still have your flame test lab results. If not, that's something you can also look up. So to get your flame test loop, this is a lot like blowing bubbles if you're using your loop. You need solution in that loop to be able to actually see the color. So you're going to pull this out. As long as there's solution in there, you're going to put it in the flame, and we're going to look for a flame test color. Now, this particular one has no flame color, and so we're going to write that down. I would typically do this in a Bunsen burner, and it tells you how to do that. If you're having a hard time, can you also soak a wood splint in here, like we did in the actual flame test lab, and use that to burn? Absolutely. Okay, I'm going to tell you don't eliminate something based on a flame test, but some of you are going to get some things that are very obvious. In fact, what would probably be a very obvious color that instantly would tell you what we had?
Green.
Green, and that would mean we had what?
Copper.
Copper. Okay, so we look at our flame test, and for this particular one, we have no flame color. And so possible ions at this point, well, we know that copper has a green flame test color, don't we? Okay, do we know anything about iron and nickel? Okay, so right now look at your packet for those two ions and see, do either one of them have a flame test?
Iron gives no characteristic flame color.
So iron has no characteristic flame color, and what about nickel?
Nope.
No, so could we still have iron and nickel?
Yes.
Yes, so my possible ions are still iron and nickel. But we have now eliminated copper. Okay? And the reasoning for this is no flame color. Okay, we've now on our preliminary test on page 5, we have completed through number 3. So we're now ready to go on to test number 4, which is dealing with dilute sulfuric acid. So we look at dilute sulfuric acid, and it says you will add half a spatula of your solid unknown to a dry test tube and add dilute sulfuric acid 1 drop at a time to the acid. Observe any reaction that might occur at room temperature. Do not add more than 5 drops of the acid. If no significant reaction occurs, gently heat in the burner flame. If nothing happens, heat the test tube more strongly, shaking it gently as you heat it so that it does not explode out the top. Do not boil acid, so on and so forth. So we are going to now perform that test. So again, I need to go back to my unknown. I need to get some more spatula, and so the first one was 1/4 of a spatula. This is a half, so it's going to be a little bit more in my test tube. So I have a half a spatula, and it says you're going to add dilute sulfuric acid to this. I want you to put out to the side. Notice it says dilute sulfuric acid. Circle what molarity is that? What does it say on number 4 the molarity is for sulfuric acid?
6.
Of course, don't have 6 mole right there. Never talked about it.
6.
Alright, all it will be right, Pat. As I am looking very quickly to go grab that, because apparently I don't have it in your tub, I need you to go ahead and look and see and kind of read through the ions that are on pages 6, 7, 8, and 9. Kind of just scan through that a little bit. Okay, so we're going to add dilute sulfuric acid to our test tube of our unknown, and I am going to make sure I add 1 drop at a time, and I want to make sure that I don't add more than how many drops?
5.
1. Alright, so I have now added 5 drops of sulfuric acid. I'm going to mix that a little bit. And as I'm looking at that 5 molars of sulfuric acid, am I having any reaction? No. Okay, so I've had no reaction with that. And then at that point, I'm also going to go ahead and heat that up. So I'm going to get a Bunsen burner. Okay, I'm going to use my handy dandy test tube clamp. And when I do this, I want to heat it gently at first and make sure it's not, the end is pointed away from anyone. So gently, and as I'm heating that gently, nothing is happening. So I'm going to try heating it a little bit more strongly, and I still have no reaction going on with this. Okay? At that point, remember this is a hot test tube, so do not put it back in your plastic rack. You can get out a trivet if you would like and put it on your trivet. And so, turn that off. All right, and so now we have performed our dilute sulfuric acid, and we are going to write up here that we have a reaction with H2SO4, and you might make sure you put 6 molar somewhere in that box. And for this case, we had no reaction. And so as we look through our packet, there are a couple of different ions that also have no reaction with sulfuric acid. And so as we look at those, this is going to be for our anions. And we're going to see that acetate has no reaction, chloride has no reaction, nitrates have no reaction, and then none of the phosphates. So we're going to say that this does not react. Okay, so now we're down to the reaction with sodium hydroxide. So for sodium hydroxide, it says you will dissolve a small sample with a spatula of the unknown, 5 to 7 drops, and then add 6 molar sulfuric. So at this point, again, we're going to go back to our unknown in our vial with our spatula. If I had used any other substance besides my unknown, I'd want to make sure I was cleaning my spatula in between each use. Okay, so now I have my unknown in there. This time, if I look, I need to add 5 to 7 drops of deionized water. So 1, 2, 3, 4, 5. I used 5 before, so we'll stick with that. Okay, my solution, now I've made an aqueous solution of my unknown, and at this point I'm going to add 1 drop of my sodium hydroxide. So here's 6 molar sodium hydroxide. I'm going to add 1 drop, and wow, I get a red gelatinous PPT. Okay, now notice it says, if no precipitate forms with an addition of 1 drop, do not add more. But if a precipitate does form, you may have to add many more drops of sodium hydroxide. Shake gently after each additional drop. So there's some different tests that are going to say that they react a certain way. We can put in a couple of drops here. Nothing really happens. It's just red gelatinous PPT. So now we're going to come up here on our reaction with sodium hydroxide, and we are going to, and I would also, folks, put here that this is 6 molar. The H2SO4 is also 6 molar. And so now I'm going to write down here that I have a dark red-brown, jelly-like PPT. Interesting. So for this particular one, I'm dealing with my cation. So look at iron and nickel and see, what does it say under iron and nickel? Anything about a precipitate with sodium hydroxide?
So
Hydroxide reacts with iron.
So for iron, hydroxide ions form colored precipitate, and for nickel, it says what? They also form a colored precipitate with hydroxide solutions, correct? But we don't know specifically what color that's going to be. So now what we have to do, we know that we either have iron or nickel at this point. Would you agree? Okay. We now are going to have to go and try a known. And at some point you will forget this, and I will do my little try a known cheer, and I will say try a known. Okay? And you will want to
Wait,
go
can you do that
try
again?
a known. Alright? What?
can you do that again?
Oh, sorry, I'll do this again. Try a known. Alright? Because some of you will forget to do that. So the knowns are actually found over here. So Colton, follow me over here. So the knowns are actually over here on the counter. And I need iron and nickel in this case. You're going to leave them on the island, but I'm going to do this test over here so you can see it more easily. So now we're going to follow the exact same procedure that we did earlier today, but with our knowns. So I'm going to take another clean dry test tube, and I'm going to take 1/4 of a spatula. Add 5 to 7 drops of water. 2, 3, 4, 5. That's what we added in our other one. And then we need to add a drop of sodium hydroxide. And notice, what do I get?
It's like the same thing.
The same thing, right? So at this point, do I probably even need to try nickel? Okay, you could if you wanted to know for sure. But if we're looking color-wise, I'm going to assume that's probably not. But to be scientific about it, we should probably try it, right? And see what happens. So now, in your lab notebook, do you possibly want to write down that we know where it said it forms a colored compound? Do you want to write down what that colored compound is for iron? I'm gonna do the same thing with no nickel, so I need to make an aqueous solution. 5 drops. Need it to dissolve. If you're trying to do a precipitation reaction, it's important that you get it to dissolve. If you can't get it to dissolve by just mixing it, what's one thing that we can do to help this to actually make it dissolve?
Heat it up.
Heat it up just a little bit. Okay, so now let's add a drop of sodium hydroxide. And we do get a precipitate, but is it the same color as our red precipitate for iron? No. So we now also know the precipitate color for nickel, don't we? And so you can also write that down in your lab packet. Okay, so at this point, we have now confirmed that we know we have which one of these, iron or nickel?
Iron.
Iron. Okay, so we have confirmed that we have iron 3+. It is a red jelly like PPT. And at this point, I might need to come back and fill some of this in, but at this point, I don't have enough information that I've found to fill in the top part of my form. At this point, we're gonna go ahead and look at the confirmatory test on the bottom. I've already worked on one of those. Okay, so we're now down here on the confirmatory test. Well, we've already done, we know that we think we have iron, but we need to look for some other confirmatory tests. So first of all, let's work on iron since we're really close and we think we know what it is. So as I look at iron, are there any additional confirmatory tests that I could try? So we look at one, characteristic flame color, that's a confirmatory, or that's a preliminary test, we've already done that. Number 2, it's colored, we've done that. They change the pH of a solution. That also matches up above, would you agree? And then our last one is hydroxide ions form colored precipitates with iron. I have not done that confirmatory test. So I now need to do that. Is there something else besides sodium hydroxide that we could use? So look at your reagents list on page 4. Is there a different type of hydroxide besides sodium hydroxide I could try?
Ammonium hydroxide.
I could try ammonium hydroxide. So at this point, I am out of clean test tubes, and so I'm going to need to wash a test tube. So to do that, I'm going to take a test tube brush. I'm going to put a drop of Dawn dish soap on the end of my test tube. I'm going to clean my test tube. My last rinse is going to be with deionized water. And now I have a wet test tube. And now I need to dry it. And so to dry my test tube, very carefully, I'm going to take one paper towel, I'm going to twist it, put it down into my test tube, twist, dry a little bit, and now I should have a clean dry test tube, okay? Looks like mine's still a little bit wet. Let's try this one more time. You will be a pro at this by the end of the week. Thanks for zooming in. All right, so I have a clean, dry test tube. I now need to try my test with ammonium hydroxide. So if I am trying a precipitate test, I need to make an aqueous solution of my unknown. Do you agree? Okay, so I'm going to make an aqueous solution. I need a 1/4 spatula of my unknown. I need to add drops of water. Colored compounds, by the way, make colored solutions, and so obviously I have a nice orangish yellow solution for my iron. And now I'm looking for ammonium hydroxide. So I found ammonium hydroxide, and I am going to see if it also forms. And notice, does it also have a red gelatinous PPT? Yes. And so at this point on my claim, I'm claiming that I have iron 3. So my claim, just in all fashion that we've done, claim, evidence, reasoning, my claim is that I have an iron 3 iron. My evidence is that it forms a what?
Red PPT.
Red PPT with, in this case it was a red PPT with ammonium hydroxide, so NH4OH. And my reasoning is then that I do have a confirmation, so a positive test for, in this case, iron 3. So yes, I have a positive test, iron 3. That is my reasoning. Based on the fact, here's my claim, I have a red precipitate with ammonium hydroxide. We know that matches what my book says, and so now my reasoning is I have a positive test for iron 3. Okay, so now I need to work on my anion. If I go back up and look, I have the options of acetate, nitrate, chlorine, and phosphate. So let's do some browsing in our packet again, and let's make sure that we can figure out what kind of test we could potentially run for my anion. So my anions start on page 8 in our packet. So we have acetate. It changes the pH, so that would potentially work. Oh, but look here, with sulfuric acid it effervesces. I don't know quite what that is, but did we have a reaction with dilute sulfuric acid? Did ours react with H2SO4? No. So probably not acetate. Let's look and see if something else matches better. Chloride down here. Oh, it says it does not change the pH of it, but dilute sulfuric acid does not usually react with chlorides. I don't know. I don't know if there's anything that totally disqualifies that, but we'll have to look and see. Phosphates would be a possibility. They do change the pH. Doesn't react with this, and so again we'd have to try silver for that one, so that could be a potential one also. And then our last one is nitrates. Dilute sulfuric acid does not usually react with nitrates. They are soluble. We can conduct a brown ring test. Since we already know how to do a precipitate with silver, we're going to go ahead and try a brown ring test so I can show you how a brown ring test actually works. And so what we're going to do is we're going to follow the instructions for that brown ring test. And so as we look at that, all nitrates are soluble in water. So we're going to do the brown ring test, meaning we're not going to find anything to precipitate with a nitrate. To do this, we're going to have to start over here, and then we're going to have to move to the fume hood here in a minute when we do that. So again, I need another clean, dry test tube. So I'm going to actually use this one over here.